This video will show a few examples on how to solve multi-step inequalities. If you have the steps, 3 steps to solving multi-step equations, you can take them out and use them to follow along. We're going to show you how to solve and quickly how to graph in the event that the problem asks you to do that. We're going to start with something simple like 3x plus 5 is greater than or equal to 20. And I'm going to change the problem a little bit here. I'm going to put a negative sign right out in front. We're going to solve and graph x. Before I can graph it, I have to first solve for x. So that means I have to isolate x. And I've only got 2 steps here, so I'm going to solve by getting rid of my 5, which is my addition. So I'm going to subtract 5 from both sides. This gives me a 0. 0 plus negative 3x is equal to negative 3x. And this is still equal to, greater than or equal to 20 minus 5, which is 15. I'm still solving for x. So I'm going to divide by a negative 3, divide by a negative 3. And here's where the only difference between inequalities and equation comes into play. You can see I'm dividing both sides by a negative. So on this side, I'm going to go ahead and put down what the result is, which is going to be negative 5. On this side, this is going to just be x. But the only difference is when I multiply both sides by, or divide both sides by a negative, I got to take this inequality symbol and switch it around. If that were a positive 3, this would still face the same direction, but it's only because I divided by a negative on both sides that I had to flip this around. Now I'm going to go ahead and graph this solution, which will give me all the solutions from the original problem. So on my number line, I'm going to identify 0, and I'm going to identify negative 5. And I'm looking for all the x values that are smaller than or equal to negative 5. So the equal to sign says start with a closed dot or closed circle. And I'm looking for numbers that are smaller than. So that would be arrow to the left. So any number on this side of negative 5 will make this inequality, and therefore the original inequality, true. The shortcut to this is if my inequality opens away from my variable, it's always arrow left. If it were to open towards my variable, then it would always be arrow to the right. The closed circle is because the symbol had an equal to sign underneath it. If I didn't have this equal to sign here, I would just have an open circle instead of a closed circle. Let's see, next example. Let's do 2/3 y plus 28 is greater than 20 plus 2y. Okay, now I could go ahead and deal with the fraction in the problem, but let's say I'm not very good at fractions, so I'm going to go ahead and eliminate or clear the fraction. And the way we clear the fraction is we undo the divide of 3. And the way we undo divide of 3 is we multiply by 3. So we're going to make everything on both sides of the inequality symbol 3 times bigger. And all that's going to do is eliminate this fraction. So I'm going to distribute here 3 times 2/3. 3 times 2 is 6. 6 divided by 3 is 2. So I'm left with 2y. And then I'm going to distribute to my 28. You might need a calculator here. So that's going to be 3 times 28, which is going to give us 84. So I have plus 84. Still have a greater than symbol or opening towards the left. Then I'm going to distribute my 3 to the 20 here. 3 times 20 will give me 60. And 3 times the 2y will give me a positive 6y. So this inequality here is still equivalent to the original problem. The only difference is I don't have the fraction. This is what we call clearing the fraction. But my result for y is still going to be the same. Okay, the next thing I'm going to do is check to see if there's any more combining on this side or simplifying on this side. Nothing there, so go on to step 2, which is move all your variables to one side. Since this variable here has a smaller coefficient, I recommend you eliminate it from this side by minusing 2y. And I have to minus 2y from the other side as well. That gives me a 0 plus 84 is still 84, greater than 60 plus 6 minus 2 leaves you with 4y. Now I just got a two-step problem in which I'm trying to isolate y. So I'm going to get rid of my plus 60 first, so minus 60 on both sides. 84 minus 60 leaves you with 24, greater than, I still have a 4y. And to detach the times 4, we're going to divide both sides by 4. So y is going to be less than 24 divided by 4 is 6. Notice the symbol did not change this time because I divided by a positive on both sides and not a negative. The same is true for multiplying by a negative on both sides. So I need to graph this. So I'm going to find my 0 here. My 6 is here. And since my inequality does not have an equal to sign underneath it, I leave an open circle, meaning here's my barrier or my boundary, but my boundary is not part of my solution. Then if I look at this, I can see that the inequality is facing away from the y, and that's always going to be arrowed to the left. There is another way we can check this. We can pick a point other than 6. Let's say we choose 0. Substitute 0 here and see if that inequality is true. Is 6 greater than 0? The answer will be yes, so I arrow in the direction of 0. Or I can simply ask myself, am I looking for values that are bigger or smaller than 6? And of course the answer is smaller, and on a number line, smaller numbers are always to the left. Let's try 8 times m plus 2 is less than 4 times 5 plus 2m, and solve for m. Okay, since I have a multiplication on the outside of my parentheses, my first step is going to be to distribute the number outside to eliminate these parentheses. That's part of the simplifying process. Distribute here, distribute here. 8 times m is 8m. 8 times the 2 is plus 16. It's less than 4 times the 5 is 20. Plus 4 times the 2 is 8m. Next thing I'm going to do is bring all my values, all my variables to one side. So I'm going to minus 8m from both sides. And it turns out that I get a 0 m's on both sides. What I have left over is 16 is less than 20. So the solution here is to ask ourselves, is that true or false? So that is true. 16 is less than 20, which means any value we put in for m will work. So the official answer is to say all real numbers.
April Bates, can you please report to the front office? Thank you.
And another way of saying that could be identity. Oops, identity. Make sure I spell it right. Now, identity is usually reserved for equations because identity means what's on the left side is equal to the number on the right. But identity also means infinite number of solutions. So even though it doesn't technically mean exactly the same thing as all real numbers, we can think of it as all real numbers. So if you put identity down as your solution for this, that would be okay. But the official answer is all real numbers. Now, if we go to graph that, the way we would graph it is draw a line with 2 arrowheads on either side. So it means every number along the number line is a solution to the original problem. And the reason is the variables cancel each other out of the problem and the inequality left over is still true. Therefore, it doesn't matter what we put in for m. What's left over will always be true. Let's try another one here. Let's do 5/6 times 12z minus 24 is greater than 2/5 times 25z minus 25. Now normally we like to clear our fractions instead of distributing them out and have more fractions, but if we look ahead, this 12 and this 24 are both multiples of 6, so by distributing my 5/6 I will actually simplify the problem. Same thing happens over here. Both of these 25s are multiples of 5, so by distributing my 2/5 it will self-clear. So we're going to go ahead and just distribute the 5/6 to both of these. So 5/6 times 12 is going to give us 12 divided by 6, which is 2. 2 times 5 gives us 10. 10z. So 5/6 of 12 is 10z. Positive times negative is negative. 24 divided by 6 is 4. 4 times 5 is 20. So 5/6 of 24 is 20. Greater than, distribute my 2/5 to my 25. 25 divided by 5 is 5. 5 times 2 is 10z. And distribute my 2/5 to my negative 25.
Melissa Watts, if you're on campus, can you call the front office, please? Thank you.
And 2/5 times negative 25. 25 divided by 5 is 5. 5 times 2 is 10, so that's going to be negative 10. Combine my z's all to one side, minus 10z minus 10z. And what I have left over, this is 0, is negative 20 is greater than negative 10. Now this statement here is false. Negative 20 is not greater than negative 10. So we would say that this has no solution.